This question asks, what is the name of the product and how many mechanistic arrows are needed to show the full synthesis of the product? So this is a multi-component question. You not only need to know mechanism, but you also have to do naming. And we also have to recognize what type of reaction we have occurring. Right, so we are starting off with 2-methyl-butane-1-ol. So we have an alcohol starting material. Let's take a look at our reagents. We have NaH, which is strong base, followed by an alkyl halide. So right away, I'm thinking Williamson ether synthesis. So let's go ahead and draw out the mechanism and then look at our product and name it. So 2-methyl-butane-1-ol. So the parent name is bute. So I'm going to have a 4-carbon chain. I'm going to number it. The alcohol is on the 1 and the methyl is on the 2. So we have a primary alcohol as our starting material. Next, let's add in our NaH. I'm actually going to help our mechanism a little bit by drawing a bond here. And then NaH, which is essentially an ionic bond. So the hydrogen is going to come around and deprotonate our alcohol. And this requires 2 arrows to show the proton transfer. The product that we make is an alkoxide. And we're going to add a primary alkyl halide with 2 carbons. And we're going to have an SN2 reaction occur. So SN2 is simultaneous nucleophilic attack and loss of a leaving group, which will require 2 arrows. Our final product is going to be an ether. And when we name ethers, we're going to look for the longest continuous chain of carbons to be the parent. So on the right-hand side, we have 2. On the left-hand side, we have 4. So the parent name is going to be butane. Ethers are pretty low on the totem pole of functional groups when it comes to naming. And so alkanes have higher priority than ethers do. And so the ether in this case would be a substituent, and it's going to be an F-oxy substituent. So all of our answer choices have F-oxy as the possible name. The tricky part is kind of figuring out the locants and where they're at. So in this case, the F-oxy is on the 1. So right away, I'm going to cross off D and E. Next, we have a methyl group on the 2-carbon. So we need to have a 1-S-oxy and a 2-methyl. And answer choices A, B, and C all have that. So the distinguishing factor between our last couple of answer choices is number of mechanistic arrows that we needed for the mechanism. And if we count our arrows up, we needed 4 total mechanistic arrows. And so our answer is going to be B, where the name of the molecule is 1-ethoxy, 2-methylbutane, and we needed 4 mechanistic arrows to show the Williamson ether synthesis.